Welcome to another physics class. In our last lesson, we promised today that we are going to coefficients of friction in horizontal plane. And don't forget, by then, we said coefficients of friction, mu, is equal to the limiting frictional force over normal reaction force. That is, this mu stand for coefficients of friction, F stand for limiting frictional force, and R is the normal reaction. Now, today, we want to look at the effect of these coefficients of friction when a body is in horizontal plane. And if you are just joining us, please don't forget to like, share, and subscribe. So when I upload a new video like this, you will be able to get the notification in time. Now, to study the effect of these coefficients of friction in an horizontal plane, let's assume this is a rough surface table and a wooden block is placed on it. This is a wooden block now. The weight is acting downward. Call it W. The normal reaction will act upward. That is R. Then, for this one to be in equilibrium, there are 4 forces that will act on it. We've mentioned 2. 1, the weight of the block itself. Then, the normal reaction, R. Then, the applied force, P. And the last one is the frictional force, Fr. Now, for this body now, let's say this is a wooden block placed horizontally on this smooth or rough surface. Now, as I said, for the block to be in equilibrium, for the block to be in equilibrium, four forces must act on it. 4 forces. 4 forces must act on the wooden block. Number 1 is the applied force. The applied force, which is labeled P. Number 2 is the frictional force. The frictional force, which is labeled Fr. And number 3 is the weight of the block itself, weight of the block. And the number 4 force is normal reaction force. This one is denoted by capital R. The 4 forces are divided into 2 components. The 4 forces are divided into 2 components. The 4 forces are divided into 2 components. A, we have the vertical component forces. Vertical component forces. According to what we have on the board, the forces that are vertical are 1, weight of the body and the normal reaction. Which are weight of the body, weight of the block, Then 2, the normal reaction R. Normal reaction R. This one is denoted by capital W. Then the second one, which is B, is horizontal component force. Horizontal component forces, which are the applied force, P, and the frictional force that will oppose the applied force. 2, the frictional force. So these are the two components of the forces. The next thing is, let's look at the equation of the forces for this block now to be in equilibrium. That is, this block to be in equilibrium, what are the possible equations that we need for these four forces? We've divided the forces into two components. For the vertical component now, vertical component, the vertical component force involve the weight and the normal reaction. So for this body to be in equilibrium, the resultant vertical forces will be equal to the resultant vertical forces is given as R minus W equal to 0. Why is it minus? This is R, this is W. R is going up, that's the direction of normal reaction, as we define it in our former lesson. The normal reaction is that perpendicular upward force, while weight of this block will act downward. So they are in opposite direction. That is why we say R minus W is equal to 0. That's the resultant vertical force. So from this one now we can now say R is equal to W. And don't forget, W can now say but W is equal to mg, that is mass multiplied by acceleration due to gravity. So we can now have, for the vertical component, we are going to have R will be equal to W, which is equal to mg, where R is normal reaction force, W is equal to weight of the block, then m, that is mass of the block, and g is equal to acceleration due to gravity. Acceleration due to gravity. Now for horizontal component, the horizontal component forces are the applied force and the frictional force. So if you look at it together also, the resultant horizontal component, the resultant horizontal component force is given as, that will be, the applied force is in this direction, the opposition force, which is the frictional force, is also equal in the other direction. So we are going to have P minus Fr is equal to 0. That is, when it is not, when there is no acceleration, when there is no acceleration. So our P minus Fr will be equal to 0. So therefore, our P also will be equal to Fr. But mind you, don't forget, this one is the frictional force, and we call it limiting frictional force. And the magnitude, as we said, from this place, the magnitude of Fr from this place, from note, from mu is equal to Fr over R. Therefore, our Fr is equal to mu R. So this one now, the applied force will be equal to Fr, which is equal to mu R. Now, if this body need to move forward or need slightly move forward, then we need to consider the acceleration. So the accelerating force, the resultant force now, if there is acceleration, now the resultant accelerating force from this one will now be equal to P minus Fr is equal to ma. Why is it A? Because the normal force, our F is equal to ma. So this is the accelerating force. Accelerating force. By the time we equate it to this one, then we are going to have P minus Fr is equal to ma, where P is applied force, then F is the frictional or limiting frictional force, limiting frictional force. The mu there, we are familiar with that one, that coefficient of friction, coefficient of friction. The R there is normal reaction force. Now, from the explanation we have made and the series of equations we've arrived at, let's use them now to solve some questions. Take this one as example 1. A trolley vehicle is slightly put forward. The question under it now, name the vertical and horizontal component forces that we act on the vehicle to be in equilibrium, and state the direction of each force. Now, solution to this one. If you are following me from the explanation, this question is just repeating what we have said so far. Let's put it in form of drawing. Let's say this is the smooth table, and let's say this is the trolley vehicle. Let's say this is the trolley vehicle. And is slightly put forward. Then there is forward force like this, which we call applied force, that we call P. When it be put forward, the frictional force will act in the opposite direction. Then the weight of the vehicle itself will act downward, while the normal reaction, that is the perpendicular upward force that press the vehicle to the solid surface, will act upward. Now, according to the question says, name the vertical and horizontal component force. Now, the first one now, vertical component force. Vertical. The first one is R, which is normal reaction. Normal reaction. And again, the question says we should state the direction. This one will be northward direction. Northward direction. The second one, which is vertical, is weight of the vehicle. Weight of the vehicle. And what's the direction of this one? Southward. Southward direction. That is the two component forces that we act on the trolley vehicle. Then, horizontal component force now. Horizontal component force. According to the diagram, the first one is applied force. And the direction of this one is what? Eastward. 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 The number 2 force is the frictional force. And the direction of this one will be westward. Westward direction. So, we've answered the question now. Let's take this one as example 2. The frictional force between a body and the plane surface is 20 Newton. If the mass of the body is 5.0 kg, calculate the coefficient of static friction between the two bodies, that is, between the body and the plane surface. Now, let's solve this one. Solution. Let's list out the parameter given in the question. Friction force is given, Fr, as 20 Newton. Then, mass of the body, M, is given as 5 kg. Then, G is given, 10 meter per second square. 10 meter per second square. Then, to find the coefficients of friction, of static friction, mu, is not given. Don't forget our formula, that mu is equal to Fr over R, where R is the normal reaction. But in this question, normal reaction is not given. But don't forget that you can now say, but our R is equal to W, that is weight of the body. At the same time, weight is not given. Then weight is equal to mg. So from there, we can now calculate our R. M is given. That's 5 multiplied by 10. That's 50 Newton. Now, since we know our R now, which is normal reaction, mu now can be equal to the coefficient of friction is 20 Newton. That's 20 over 50. And that one will now give us 2 over 5, which is equal to 0.4. And don't forget, in our last lesson, we said coefficients of friction, either static friction or kinetic friction, is a dimensionless quantity, that is, has no unit. Since this one is force, if you take Newton as unit, normal reaction is force. If you take Newton as unit, so the Newton will go away, so we have 0.4 without unit. Let's take this one as example 3. A vehicle of mass 300 kg moves with an attractive force of 2,500 Newton over a horizontal road. If the coefficient of kinetic friction is 0.4, find the acceleration of the vehicle. Now, from this question let's write out the parameter given. Mass of the vehicle is given. Mass of the vehicle is given m, 300 kg. Then the question you had, g is equal to 10 meters per second square. Then the attractive force, that's the applied force. Let's call it P is equal to 2,500 Newton. Then mu is given, mu, which is coefficient of friction, as 0.4. Then G is also given. G is equal to 10 meters per second square. Now, we have to calculate A, the acceleration of the vehicle. Now, from the one of the formula given in the question, in our explanation, we said we have P minus Fr is equal to ma, where this our P, according to the question, is the attractive force or the applied force. From the question, the limiting frictional force or frictional force is not given, and N is given. We have to calculate A. So here now, let's P is 2,500 Newton, M is 300 kilogram. Now, we can now say, but this our frictional force is equal to mu R. Now, from there now, we can now say coefficient of friction is given. Our R also is not given, so we can now say mu, since this one is mg. Normal reaction is mg. So we can now say that will be 0.4 multiplied by 300 multiplied by 10. And from this one will now give us 1,200 Newton. 1,200 Newton. So it means the frictional force is equal to 1,200 Newton. Now, from the first equation on the board, we can now say P minus Fr is equal to ma. That will be 2,500 minus 1,200 is equal to 300 A. 2,500 minus 1,200, that will be 1,300 equal to 300 A. So A now will be equal to 1,300, then divided by 300. 0 will cancel, so we are at 13 over 3. And the answer for the acceleration of the vehicle will be given as 4.333 meter per second square. That's the acceleration of the vehicle. Let's take this one as example 5. Sorry, example 4. A wooden block of weight 16 Newton is placed on a rough surface if the coefficient of the static friction is 0.25. Calculate the horizontal force required to move the block. Here now, let's write out the parameter. The weight of the block, W, is given as 16 Newton. Then, coefficients of static friction, mu, is 0.25. And that's all. Then we now have to calculate the force required to move the block. That is the applied force, P, unknown. Now, from the series of equations we arrive at, one of the equations says P minus Fr is equal to ma. Don't forget, the question says static friction. It means there will be no acceleration at all. So you can now say A is equal to 0. Why? No acceleration. If A is equal to 0, then we are going to have P minus Fr is equal to 0. Then our P will be equal to Fr. Now in the question, Fr is not given. So we can now say that but Fr is equal to mu r. Mu is given. Now, if we put it into drawing, let's say this is the wooden block, this is the applied force, this is the frictional force, then the weight acting downward is given as 16 Newton, and the normal reaction, R, is up. Don't forget, according to what we said the other time, for this block to be in equilibrium when it moves by static friction, we said R must be equal to W. Don't forget that. It means our R also will be equal to 16 Newton. If that is the case now, then mu is given. So our Fr will be equal to 0.25 multiplied by 16. Now, the frictional force is equal to 4 Newton. That's 4 Newton. It means the applied force now, since we said P is equal to Fr. So, the force required now to move it up, since P is equal to Fr is equal to 4 Newton. Let's take this one as example 5. A metal box of mass 4 kg rests on top of metal surface. If the coefficient of friction is 0.42, what force applied parallel to the surface is required to A. Just move the box, B. Move the box with acceleration of 2 meters per second square. G is equal to 10 meters per second square. First, write out the parameter given in this question. The mass of the metal box is given as 4 kg. Then, the coefficient of friction is given, mu, as 0.42. G is given as 10 meter per second square, 10 meter per second square. Then, according to the question, we have to calculate the force required to just move the bus. That is static friction. And the second one, move the bus with an acceleration of 2 meters per second square. That is kinetic friction. If it is static friction, answer to A now. We now say P minus FR equal to MA. But under this one, A is equal to 0. Don't forget, static friction, no acceleration. If that is the case, our P now minus FR will be equal to 0. So P will be equal to FR. And FR is what? That one will be equal to mu R. Mu is given, then R is indirectly given. So we can now say mu mg, since normal reaction is equal to V and V is equal to mg. So we can now say that the parallel force that must be applied to just move the box will be equal to 0.42 multiplied by 4 multiplied by 10. And that parallel force, P, will be equal to 16.8 Newton. B now. The force required if the acceleration is 2 meters per second square. Using the same formula, our P must be minus FR, which is equal to MA. Now, since A is given, so we can now say that P now will be equal to MA plus FR. And M is given as 4. A is given as 2. That will be 4 multiplied by 2 plus, don't forget, we've calculated this FR here, which is 16.8 Newton. So to not waste our time, already we've known that FR is equal to mu multiplied by M multiplied by this one. And it has been calculated here. That will be plus 16.8. That one will be 8 plus 16.8. And this one will now give us 16.8 plus 8. That will give us 24.8 Newton. 24.8 Newton. That's the solution to this question number 5. And this is convenient point to stop for now. In our next class, we are going to have more examples under coefficients of friction in horizontal plane. So more examples will be given by then. And don't forget, as I said, this platform is meant for all the category of exam that if you wish to write, that you can join physics in maximum rate when you join us on this platform. As the name of the channel implies, that is free physics from the grassroots. So if you are just joining us, we have been taking the topic from one topic to the other. So if you are just joining us, please try to like, share. So when I upload a new video like this, you'll be able to get the notification in time. Thank you.